All right, welcome. Derek Deville here from Miami, Florida. Got the Black Dragon with me. It's this 18-inch diameter, 26-foot tall rocket that I designed especially for the motor. The motor is 8 inches in diameter. It's a 60-61 aluminum tube, almost 5 feet long, just a little bit short of 5 feet. And the reason it's this length is because I'm using 4-foot long liners for insulation on the inside. So the motor was designed around using a single 48-inch long piece of insulation. The end closures are held in place with radial bolts. These are countersunk. So on the forward side, once those bolts are cinched down tight, they're below flush, so the motor can be inserted and removed easily. There's aluminum rings that go for retention. Keep this in place. So slide that bad boy in there like that and line up the screws and off you go. And then the forward bulkhead is similar. The forward bulkhead is a CNC 2-inch thick piece of aluminum that's been milled out to make it lighter and stronger.
Does it have any O-rings on it, or is it just sliding like the
O-rings? Yeah. There's actually, the nozzle. Let me get a little bit more on the nozzle. The nozzle is a phenolic insulated. It's two pieces of phenolic sheet, 3-inch thick phenolic sheet that have been bolted together. That's what these bolts are here for. And they've been bolted and glued together, and that's been machined. And then there's a graphite insert. So there's two O-rings that seal the graphite into the insulator, and then 2 O-rings on the outside that seal the phenolic to the outside of the case. Okay. And there's also 2 O-rings on the forward bulkhead.
And what did you use for your liner material and your casting tubes?
The casting tubes are paper, and the liner is paper phenolic, craft phenolic.
So this is something you can buy from Pat G?
Yeah.
He sells them? Or he can give them to us?
Well, Pat, yeah, I got the liners from Pat. I don't know where he got them from.
Plaid?
This is a white flame. This is this propellant actually was the original propellant that I started to design the CSXT propellant from. So this was the base propellant that later became the CSXT. We had to slow this propellant down. This is a faster burning propellant. I call this Deep 6. And so it's got red iron oxide for burn rate catalyst. It's got some mag and some aluminum, some really fine aluminum to keep the burn rate up. It's trimodal, and it's pretty liquid. It's very pourable. It's very easily processable. And the whole goal with this was keep it simple and make it easy and doable. So the grains are 12 inches long. Each grain was cast 1 grain at a time. I have a casting base with I used aluminum tubes with Teflon coating on them as mandrels. Pop a grain on there, pour it just to the right level and stop, and then trim off the excess paper and smooth out the top of the grain. And then there's 4 grains. The top grain then is just trimmed to make it fit right.
Okay, how are you going to light this motor?
I don't know, I haven't figured that out yet. I don't know, just a regular old igniter, probably a couple of Pyrogen dip Davy fires and a sliver of Blue Thunder, and I'm not a big thermite fan, so okay. I'm gonna go with the old school. Nose cone was made by Rick Waters and Chris Standish from the Big Daddy project. They donated that to me after some motors that I made for them. Body tube, sonotube, got a wooden truss structure going up the middle, screwed to the outside of the frame. Brings us down to here. The fins are carbon fiber fins, 1-inch thick closed cell polyurethane foam with 2 layers of carbon over them, vacuum bagged. These are held in place by an aluminum support structure. Weld aluminum frame. The bow tail, so the motor is going to slide in here. There's a little bit of extra tolerance here. The bow tail will actually help center the motor, and the motor bolts onto the cross form that's up there where the chutes attach. And then the tail cone is notched out because there's a foot that's part of the rail that is going to support the rocket and bear the weight on the aluminum frame, so that none of the composite parts have to bear the load. So this will get mounted on here, something like that. And the motor sticks out just about 3/4 of an inch beyond this. Just a little quick something on carbon fiber I popped out night before last. No, the fins are closed cell polyurethane foam, 1-inch thick. And what I did there was I took masonite, 1/4-inch masonite, cut it out to the shape of the fin that I wanted, and then bolted that on either side of the polyurethane, cut out the outside form, and then hand shaped the leading and trailing edges, and then laid it up with the carbon fiber. And the carbon fiber actually wraps completely around the leading edge of the fin. So it's continuous fabric up one side, over the leading edge and down. So there's no seams on the leading edge to catch wind and peel it off.
How many reps you have?
2 layers on either side. It's a layer of 7 ounce and a layer of, I think it's about 10 ounce on top of that. That's
right. How these things get removed? They look like they're removable.
Yeah, the whole thing is removable. These screws here are what kind of keeps this in place. When you pop all these screws, this whole thing will slide out the back, and then you can unbolt the fins and remove the fins from that.
And how much does this fin can with the aluminum weigh?
About 59 pounds, fin can and fins.
All right.
So it's a little bit heavy, but it's got to be strong. So we're expecting this thing to go supersonic. So it'll be, we're expecting about 14,000 plus on the altitude with the motor. And the motor's 2,400 pounds of thrust for 8 seconds. Got an HD camera on board, a couple of dual adepts, and an RRC missile works. So these are the lines. The altimeter bay is actually right here. It's a 4-inch by 4-inch altimeter bay that's 14 inches long. This is the vent for the altimeter bay. It's completely sealed to the side of the airframe, so it's a single vent point. And then wires will come out through the electronics are mounted on a board that has the coupler for this. So you drop the electronics in and screw it in. And then this wire comes from the bulk plate up there and ties to the ejection charges. This is the wooden cruciform this is biaxial fiberglass tape bonding the cross form together. It's 2 giant pieces that have been interdigitated. And then here's the Kevlar shock cords which come down. If you swing around this way, you can look back in there and see the motor support. Those are the C channels that bear the thrust of the motor, transfer the thrust into the cruciform thrust plate, or thrust form, and also transfers the load into the fins. Oh, another neat thing is the rail guides. I don't know if you can drop down underneath here. The rail guides are little trolleys. This is ball bearing steel wheel trolleys that mate to Unistrut. There's a 4-wheel set here, 4-wheel set at the bottom, and then a single wheel set up at the top to keep it from pivoting around any. Interesting things that you don't often see: 1-inch diameter holes in the side of the airframe. These are vent holes. When you have such a large airframe, the interior pressure is at full atmospheric pressure on the ground, but by the time you get up to 15,000 feet, which is the anticipated altitude, the atmospheric pressure is down to 8 psi. So all that change in pressure has to vent out of the body tubes to keep them from building up pressure and possibly bursting the tubes. So that's what the vents are for. There's vents up in here. There's a bulkhead here. All right, so recovery section is from here forward. There's a bulk plate in here. The hardpoint mounts for the chutes are actually down on a 3-inch wide aluminum C channel that bolts to the forward end of the motor. So the chutes are attached directly to the motor, and they pass through the body tube and then through cutouts in this bulk plate and attach to the chutes. The chutes are in this compartment. This compartment's vented for relief, and then the charge will be placed in here. Some wadding, chutes in here. The shoulder and nose cone's 18 inches long, comes down to about here. There'll be 6 number 6 nylon screws here retaining the nose cone on the way up, and then those will get sheared at apogee. The nose cone it's an all carbon fiber nose cone. It's been reinforced on the inside, and it's foam filled up to about here, and then it's a custom carbon shoulder that comes back into there. There's 2 chutes, one main chute for the body tube, 25-footer man rated chute, and then a Rocket Man R14 for the nose cone. What else can we got? We got 36 grams of black powder in this thing, so we're gonna blow it out or blow it up. The rocket's called the Black Dragon. There's actually a cigar. I'm not a cigar aficionado, but there's a cigar called the Black Dragon. It's the most expensive cigar in the world. It's $1,100 per cigar. So, in keeping with the vein of premium quality.
Well, we'll meet you out there at the pad when you're ready to put this thing up.
Sounds good. We'll see you there.
All right, good luck.
Thanks.